Hello everyone, we're on question 10 now of paper 2 from 2024, and let's have a look what it says. Figure 4 shows the sketch of a curve C with parametric equations x is equal to t add 3 squared and y is equal to 1 minus t cubed, where t is in between 1 and minus 2. The point P with coordinates 4, 2 lies on C. Using parametric differentiation, show that the tangent to C at P has the equation 3x add 4y equals 20. So I've drawn a sketch here and I've drawn a tangent to the curve at the point P, which I've labelled there 4, 2. So this is going to be an application of the chain rule. So in other words, we're going to be using the fact that dy by dx is equal to dy by dt times by dt by dx. So that's an application of the chain rule. So we need to differentiate our y and differentiate our x with respect to t to start off with. So y is equal to 1 minus t cubed. So therefore dy by dt is going to be minus 3t squared. So that's the first bit differentiated. Let's differentiate the x. We have t add 3 all squared. So using the chain rule, that's going to go to 2 times t add 3. We technically need to think about differentiate, timesing that by the derivative of the inner function. However, in this particular case, the derivative of the inner function is 1. So technically, we've got to times it by 1. Now we can bring those two things together and write down that dy by dx is equal to dy by dt times by dt by dx. So that becomes dy by dt times by dt by dx. So there's our expression for our dy by dx. Now, what we need to do is, in order to find the equation of the line, there's two things we need. We need a gradient and we need a point. We've got the point P, which we know has the coordinates 4, 2. So all we need now is just to know the value of the parameter at dy by dx. So let's take if necessary, we could solve it for both x and y to see what value of t we get, okay? But in practice, as you'll see in a moment, when we solve p, we don't need to go any further, and I'll explain why. So we know that at the point P, that the x coordinate is 4. So I'm going to solve 4 is equal to t add 3 all squared. So we're going to have 4 is going to equal t squared add 6t add 9. Take the 4 over to the other side, and that gives us t squared add 6t add 5, which factorizes nicely actually into t add 5 and t add 1, which means that t is either minus 5 or minus 1. Now, if we look at the range of values of t in the question, t is only between minus 2 and 1 in the question, so therefore this value is out of the range, so it can only be this value of the parameter that gives rise to the point P. So we don't need to do the whole process for y as well. So we've established that t is in fact minus 1. So we can now go back to our gradient equation and we can find the gradient of the curve when t is minus 1 by subbing in t is minus 1 into the equation that we got earlier. So therefore dy by dx is going to be minus 3 times by 1 squared over 2 times minus 1 add 3, which is going to be minus 3 in the numerator, and it's going to be 2 times 2 in the denominator. So minus 3/4 is our gradient. So now we have everything we need now in order to find our equation, because we have a gradient and we have a point as well. So let's bring those things together. So what we've got now is that y minus y1 equals mx minus x1. We've got the coordinate p as the y value of 2 and an x value of 4. Our gradient at the tangent we've just established is minus 3/4. So bringing that together, timesing everything by 4, gets 4y minus 8 equals minus 3x add 12, because minus times a minus makes a plus. And then adding the 3x over to that side and adding that minus 8 over to the other side, we get the equation that we're being asked to derive. So that's part A for 5 marks. Now, it says the curve is used to model a slide at a water park. The units are in meters, with y being the height of the slide above the water. Find, according to the model, the greatest height of the slide above the water, 1 mark. Okay. So, I mean, I think really, if we just have a look at the cubic equation that we've got there for y values, if y is negative, we're going to get positive values coming out of that, because what we're going to have is we're going to have 1 minus the t cubed, and the t cubed would give us a negative number. So I think really, in order to find the height, we just need to sub in t is minus 2. T is minus 2 is going to give us the greatest value of y. So subbing in t is equal to minus 2, that gives us 1 minus minus 2 cubed, so 1 minus minus 8, so 1 add 8, so 9 meters is the greatest height of the water slide above seawater level. Hope you found that helpful, and I'll see you in the next video.